Welcome to Design of Structure. In last lecture, we are going to start chapter T-beam, in which we are covered up to concept of tie beam. Now continue with the concept of tie beam. We can see that there is a T-beam divided into two segments which are separated from the main figure, which one is singly reinforced rectangular beam and another one the portion of slab. Let us define the terms. Upper width of the beam is Bf, lower width of beam is Bw, but F represent the flange, W represent the web. The lower portion of the beam is web and the upper one is flange. Overall depth is D and the flange depth is Df. But when it is divided into separating part, there is again we get the two different shape, and the distance between two shape is total difference BF minus BW. We get the distance between two segment and the remaining depth is same. Let us discuss some terms. T-beam is equal to single RC beam of size WB into D, same as plus slab portion of size BF minus BW into DF. The analysis and design of T-beam is analogous to the analysis and design. In case of doubly reinforced beam, additional compressive resistance is obtained by providing ASC in the compression zone, while T-beam is additional compressive resistance is obtained by considering slab concrete of width BF minus BW as flange of T-beam. Slab concrete can be provided this resistance only if it is suitable in the compression zone. Also, the spacing of the slab must be perpendicular to that of the beam. Flange beam also can be doubly reinforced. However, doubly reinforced flange beam are rare. A large amount of compressive force is provided by the slab concrete. Moment of resistance of tie beam. Mr of singly plus Mr of slab. Sorry for the disturbance, but there is a network problem. Uh, Steel area required for T-beam, similar as above. Stress strain diagram for the tie beam, in which we know that the cross section of T-beam like this. There are AST, BW. The steel in above portion same as the slab beam in rather than the doubly beam, WT beam section same as doubly reinforced diagram, and in this case stress diagram there is a little change in C2. In doubly beam C2 is something here, but in this case it is top of the beam because the reinforcement is covered in this case is at the top of the slab. This diagram is important in exam because this is a 1 mark question, maybe 2 or 3 mark question, as asked in exam. These are the nomenclature I already denote in previous figure. Here we have C1 force of compression in concrete of rectangle beam. C1 is equal to 0.36 FCK BW into XU. B is replaced by BW because it's in wave. Concrete C2 compression force in concrete, which is C2 is equal to 0.446 FCK BF minus BW into DF. Sorry, again it's a network problem. No, no issue. Let us continue the lecture. C2, T is equal to force of tension in steel in wave. T is equal to 0.87 Fy into AST. Z1 D minus 0.42 XU. Z2 D minus DF by 2. Now, position of natural axis. Let us assume that the natural axis lies in bottom of flange. Let, sorry, it's a very typical network problem. Let us continue. Let us assume the natural axis lie at the bottom of flange FC. FC is equal to 0.36 FCK B into XU, 0.36 BF into DF. Similarly, for FT, tension member 0.87 Fy into AST. These are the mandatory terms we need to remember and use at the taking the particular clause. Fc greater than Ft, natural axis lie in the flange. When Fc is equal to Ft, natural axis lie at the junction of the flange and wave. Fc less than Ft, natural axis lie in the wave. To find depth of natural axis XU, we have to use comparison of the force, compression and tension. Likewise, C1 plus C2 is equal to T 0.36 FCK BW into XU plus point, sorry, we need to check our network connection. C1 plus C2 0.36 FCK BW into XU plus 0.446 FCK BF minus BW DF is equal to 0.87 Fy into AST. Find value of XU by this equation. There are very mandatory equation to find out the correct situation. XU less than DF, Na lies in flange. XU is equal to DF, Na lies at the junction. If XU greater than DF, Na lies in the wave. If there is a condition between the location of Na obtained by FCFT and the location decided by equation 8, if that situation suitable df is equal to yf in equation 8 and find xu, where yf is equal to 0.15 xu plus 0.65 df. Now to decide types of beam. To decide types of beam, find xu from the equation and the condition of fu and xu max, we get the decide of the beam. Like XU less than XU max under reinforced section, XU is equal to XU max balance section, and XU greater than XU max over reinforced section, where X is equal to to max to be used. In next chapter, we are going to continue our lecture with the moment of resistance of beam. चौदह ही करना क्या